So we are given a problem relating to the Fibonacci sequence and how this specific question is defined as f0 equals f1 equals 1, and then fn equals fn minus 1 plus fn minus 2. Many Fibonacci questions or Fibonacci notation will have it's starting from index 1, but this one is starting from index 0, which is just important to note. And we're trying to show that fn plus 1 times fn minus 1 equals fn squared minus negative 1 to the power of n, where fn is the nth value in the Fibonacci sequence. And for simplicity's sake, we're going to denote this one as part 1 and as part 2, where the limit as n goes to infinity of Fibonacci number over its preceding number is equivalent to 1 plus square root 5 over 2. So we're going to start with the first part, and we are going to proceed by induction. Our base case will be n equals 1. We cannot do n equals 0 because here we'd have f negative 1, which is a non-existent value. So we'll have f1 plus 1 times f1 minus 1, which will equal f2 times f0. Given how this is defined, we will have 2 times 1. Then we can note that f1 squared minus negative 1 to the 1 will equal 1 squared plus 1 equals 2. So we have proven the base case. Next, we must proceed to our induction hypothesis, which we will just write that down here. We will assume for n equals k that this holds fk plus 1 times fk minus 1 equals fk squared minus negative 1 to the power of k. Then we will consider fk plus 2 times fk. We want to show that this equals fk plus 1 squared minus negative 1 to the k plus 1th power. Given how the Fibonacci sequence is defined, we know that fk plus 2 times fk equals fk times fk plus 1 plus fk. And in this case, we're just replacing this value here with the two preceding numbers. And then we can expand that, and we have fk squared plus fk1 times fk. Next, we can refer to our induction hypothesis here. We can note that, I'll just write this down, note that fk squared equals fk plus 1 times fk minus 1 plus negative 1 to the kth power. We are just moving this over to this side here. Then if we implement this substitution, we have fk squared plus fk plus 1 times fk equals fk plus 1 times fk minus 1 plus negative 1 to the k, just doing the substitution here, plus fk plus 1 times fk. And we are just going to put all the Fibonacci terms to the left here. So we'll have fk plus 1 times fk minus 1 plus fk plus 1 times fk plus -1 to the kth power. We can factor out the k plus 1 here, so we'll have fk plus 1 times fk minus 1 times fk, or no, plus fk plus -1 to the power of k. Here, we can see that this actually just equals fk plus 1. So we'll have fk plus 1 squared plus -1 to the k. Then we can note, given the property of -1 to an integer exponent, we know that plus -1k will equal minus -1 to the k plus 1. Therefore, we have fk plus 1 squared minus, I'll just write that more clearly here, minus -1 to the k plus 1, which is what we wanted to show. Therefore, we are done the first part of the question. Next, we will do the second part, and we want to consider the limit as n goes to infinity of fn divided by fn minus 1, and we will assign this an arbitrary value, which we will denote as x. Then we can say that because of how the Fibonacci sequence is defined, that we have fn minus 1 plus fn minus 2, this is just fn, divided by fn minus 1, which if we just separate these parts of the numerator here, we'll have fn minus 1 over fn minus 1 plus fn minus 2 over fn minus 1, which just equals 1 plus fn minus 2 over fn minus 1. This value here, 1 plus fn minus 2 over fn minus 1 equals x. We can note that this value gets larger quicker than this value. So we have 1 plus 1 over x equals x. If we multiply the equation entirely by x, we will have, alternatively, x plus 1 equals x squared, or x squared, moving everything here to the right, minus x minus 1 equals 0. Now, we can use the quadratic formula. Just write this as QF. And that implies that x equals 1 plus minus 1 squared plus 4 over 2. We do not consider the minus here because this is going to be a negative number at the top, and the Fibonacci sequence is only working with positive numbers. So we will just have 1 plus root 5 over 2, and we are done the second part, and therefore are done the entire question.